Hello, this is Sigma Bob. In this video, I will be discussing problem 20 from the AMC 10 2024A. We will carefully examine the problem statement, identify the key idea required for its solution, and work through the steps in a clear and systematic way. Let's get started. Here is problem 20 from the AMC 10 2024A. Let S be a subset of 1, 2, 3 all the way to 2024, such that the following two conditions hold. If x and y are distinct elements of S, then the absolute value of x minus y is greater than 2. If x and y are distinct odd elements of S, then the absolute value of x minus y must be greater than 6. What is the maximum possible number of elements in S? Space the odd numbers as closely as allowed, and then fit as many even numbers as possible between them. Pause the video here if you'd like time to solve the problem yourself. Now, let's go through the solution. The odd elements of S must be more than 6 apart, so the smallest possible spacing between consecutive elements that are odd is 8. To maximize the size of S, we can start with the sequence 1, 9, 17, 25, and further on, which consists of numbers of the form 8k plus 1. The largest odd number in this sequence that does not exceed 2024 is 2023. Solving 8k plus 1 equals 2023 gives k equals 252, so there are 253 odd numbers in the sequence. Now consider the gap between two consecutive odd numbers, such as 1 and 9. Because every pair of elements in S must differ by more than 2, we can fit at most one even number between them. For example, 5 can be included, but no second even number can be added without violating the spacing condition. There are 252 gaps between the 253 odd numbers, so this contributes 252 even numbers. At the end of the interval after 2017 and before 2024, there is enough room to fit two additional even numbers. Therefore, the maximum size of S is 253 plus 252 plus 2 equals 507. However, this arrangement is not optimal. Shifting the odd numbers farther apart to a pattern such as 10k plus 1 creates larger gaps, allowing even more even numbers to be inserted. Repeating the count with the spacing of 10 yields a total of 608 elements. Any larger spacing is less efficient since it reduces the number of odd numbers too much and cannot make up for the loss with additional even numbers. Therefore, the maximum possible numbers of elements in S is 608, and the final answer is choice C, 608.